This problem, we are to simplify and write the following trigonometric expression in terms of just sine and cosine. So one way to do this is to simply start swapping out each of these identities that's not a sine and a cosine. So for example, secant t can be written as 1 over cosine t. And by the way, the reason this says method 2 is I just recently made a video showing how to do this problem in a different way. And I wanted to show off the different aspects of algebra. So this is just a way of doing the problem where you take secant and swap it out for cosines, where using the identity that secant is the reciprocal of cosine. So secant is 1 over cosine t. Now, because my final answer is supposed to be written as some equation squared, and that's what this means over here, you are to ignore the right-hand side for the time being. This is just a teacher's way of saying, look, we want you to write this identity down and work on it until you get your answer in the form of some equation squared. So it just turns out at the end of the problem, you'll end up with a single trig function squared, and that's just our way of telling you the structure of the answer without actually giving you the answer. So for now, I'm just going to keep working on this till I get it as a single trig function. So to do that, I'm going to need to find a common denominator here. So the common denominator between 1 and cosine t would be cosine t. So to make this denominator cosine t, you can do this by multiplying the denominator by cosine t. But if you multiply the denominator by cosine t, you should multiply the numerator by cosine t to make it legal. What I mean by that is now we have cosine t over cosine t, which is can be simplified down to be the number 1. So think of this as a clever way of multiplying by the number 1, and multiplication by 1 doesn't change things in mathematics. So this right here is still the function cosine t. Now that I've done that, I can subtract the numerators. So remind yourself in arithmetic that if you have two fractions with a common denominator now, you subtract the numerators, meaning 2 minus 1 is 1, but you do not subtract the denominators. That would be bad. If you did that, you'd get 0. So you don't subtract the 5s. You don't end up with a 0 in the denominator. You just end up with 5s. You copy the denominators. So what I'm going to do here is write this as 1 over cosine t. Try not to skip steps, so you can fast forward the video if you already know this. Cosine t times cosine t is cosine t squared. Just like in an algebra class, if you had y times y, you'd write it as y squared. So cosine t times cosine t is cosine t squared. We have a short way of writing this. We typically write it as cosine squared t, where we put the 2 here rather than here. And it does avoid these parentheses and makes it look a little cleaner. A problem with this, again, is students think that the t is being squared, and it's simply not true. It's the entire cosine t that's being squared. At any rate, now that I've done that, I'm going to make the argument, and don't forget I have all of this is over 1 over cosine t here. Haven't forgotten about that. That we're simply going to subtract the numerators just like you do with arithmetic. Remember that functions really aren't that much different than numbers. After all, if you gave me a t value, I'd evaluate this and this would become a number. So I think of functions as, the rules for working with functions is the same as the rules of working with numbers. So now that I have a common denominator, I can write this as 1 minus cosine squared t. By the same way you'd take 2 and subtract the 1 to get 1, I'm taking 1 and subtracting cosine squared. And here we did not subtract the denominators, we just copied them. Same thing here, we have cosine t here, we have cosine t here. So I'm going to copy that as cosine t. And then rather than writing this as all being divided by 1 over cosine t, it's often easier to explain as if I write it horizontally, as instead of this big division bar, just writing a division symbol. So this is all being divided by 1 over cosine t. See if I can squeeze it in here. Then bring this over here to give me some more room to write. Let me copy this. Now if you remember how to divide fractions in math, one does this by changing the division to a multiplication. So this division right here, I'm going to change right there. I'm going to change that to multiplication here. And then I'm just going to reciprocate this, so it's cosine t over 1. I meant to change that back to blue. Anyway, so with division of fractions, you change it to a multiplication, you reciprocate the fraction, and then because this is a factor, right, all of this can be thought as being multiplied by cosine t. In fact, if you had to, you could distribute this across. So this cosine t is being multiplied by that entire construct over here. That makes this a factor, meaning that this entire thing is a factor. This is a factor down here, and since they're being divided, anything divided by itself is 1. So I'm going to simplify that down. We say canceling, but really what I'm saying is cosine t divided by cosine t is the same thing as 1 divided by 1. So some teachers will make you put the 1 in there to remind you that you're not canceling, you're really simplifying down to be the number 1, and then we don't write multiplication by 1 in mathematics because it doesn't change the value of anything. Now this 1 minus cosine squared, you'd think that I'd be done now because the problem said, you know, simplify and write the trigonometric expression in terms of sine and cosine. So I'm done. I wrote it in terms of a single trig function, but this is where this part here comes in. It says keep working on the problem until you get the structure where you have a single equation being squared. Well, I don't have that. If it wasn't for the 1 minus, I would have cosine squared and the answer would be cosine there. So what I have to do is swap this out for a single trig function. So off to the side, I'm going to make this argument that since sine squared, I'm going to use the variable t since that's the input being used in this problem. Remember that sine squared plus cosine squared is equal to 1, one of the most common identities I use. So if you get used to seeing this over and over and over, then hopefully you notice that this is just a variation of this, meaning if I was to simply subtract cosine squared on both sides of the equation, this would cancel. Now, what you're really doing is saying that when you have something and you subtract that same thing, it sums to 0. Just like 7 minus 7 would be 0, I've got cosine squared minus cosine squared, so that's 0. And in mathematics, you don't need to write addition of 0 because it's the additive identity. It doesn't change anything. So we don't write the plus 0 any more than we multiply by 1. We usually don't write that either. So simply taking the Pythagorean identity, sine squared plus cosine squared equals 1. This is just rote memory. So if you wonder where I pulled it out of the air, that's just something you're supposed to have memorized by now. And hopefully we prove to you that it's true, but at some point you just know that by rote. So all I did was take that Pythagorean identity that you're supposed to take for granted, subtract the cosine squared over. Over here, these canceled, if you will, or summed to 0. And then on the right-hand side, you'd have 1. And then we subtracted the cosine squared over. So this is just a rewrite of the Pythagorean identity, so this could be thought of something you could memorize as well and take for granted. So what I have over here is the right side of that identity. I have 1 minus cosine squared, and this says that it can be swapped out for just sine squared t. So this is equal to sine squared t, which is just a shorthand way of writing that we have the sine of t all being squared. So remember, we're supposed to work on this problem until we get an answer that is some trig equation squared, and we've done that. The answer is sine t. Rather than you writing the whole answer in, which is this. This is the, we worked on this trigonometric expression and we simplified it down to this. We're done. But to appease Math AS, it says we're going to make things a little easier for you. You don't have to write the 2. That whatever the function is, the equation that's being squared, please just write it in this box. So that would be sine t here. And in Math AS, I believe, I might be wrong, but I believe you have to put the t in parentheses or it will not grade you, it won't give you credit for the problem. So you'd have to put the parentheses, I believe. You'd have to try that out. So this is just another way of doing the same thing I did in Method 1, but shows off a little bit different mathematics in the solving part.